I think actually the best place to start is the basics of quantum computing versus accelerated or supercomputing. Because if you explain why that 13,000x performance is notable in simple terms, it gives some measure of why it's a piece of news this week.
Absolutely. Today's computers, classical computers, they use bits, right? Zeros and ones. They use that to calculate. It's useful for a number of different problems across the world. However, quantum computing is different, uses a combination of zeros and ones at the same time. That enables access to different types of problems, like the quantum echoes algorithm we announced this week.
You have brought Willow with you. You've put it in an impenetrable, safe housing and casing. There it is on the desk in front of me. I read a lot of academic papers this week, and many point out that you didn't use a scalable or fault-tolerant chip for this demo. And so the argument follows that it would be a big challenge for you to commercialize or scale out that technology. Is that a fair concern from the academic community?
That is the goal of quantum computing, to get to fault-tolerant quantum computing. Nobody is there yet. It is a long journey, but it is very exciting. We've been excited last December to announce for the first time that error correction can work. We demonstrated that with our Willow chip, and we continue on this journey, pushing the number of qubits and also bringing the errors way down.
And it's the timing now, Karina. What is it, 5 years till we get something that actually will show quantum computing being really applicable and useful in the areas of science, in the area of medicine? Why that timeline in particular?
Yeah, we are optimistic that we'll see real-world applications that are only possible on quantum computers in the next 5 years. This breakthrough that we announced this week is a great milestone towards that path. We showed that quantum echoes, this algorithm, is not only 13,000 times faster on a quantum chip, but that it can be used to simulate and calculate the exact structure of a molecule. So we think this is an important step on the path.
Someone on your team won the 2025 Nobel Prize in Physics, was among the winners. You have Hertman leading the charge. We have real stellar talent, but also a lot of investment. What did you make of the news, the flow that maybe the US government is there to support other smaller quantum players here in the United States? Is that important?
Yeah, we are really excited and pleased to see all of the investment, the support, the excitement about quantum computing across the board. The U.S. government has been a strong supporter and partner in this for the last many years, and we're very excited about those investments and continued partnership across the ecosystem.
Karina, you are the COO of the Quantum Group, right? And we reflected earlier in the week on the show when the headline hit the Bloomberg about this breakthrough. Actually, markets reacted. Alphabet shares moved markedly. Would you reflect a little bit on what the days that followed that were like? Did the phone ring off the hook from various parties that are interested now to know more about how they might be able to use the tech?
Yeah, for us at Google, we are really excited about all the interest that we're seeing across the board. Our mission at Google Quantum AI is to build quantum computing for otherwise unsolvable problems. I think that's why there's increasing interest with every breakthrough. People in other fields are getting excited about what can be possible, and we look forward to continuing.
So the bar has been set now for you. What is the next milestone that we should judge you by in progress?
Yeah, there's going to be continued work across the board. One really important marker of progress is continuing to push the hardware. So you can see on this Willow chip here, it says 105Q. That's 105 qubits on our Willow.
Too fast. Give the cameraman a chance to catch up, but he will get it. Yeah.
All right.
Keep going.
Yes, 105 qubits. So that is great. This has been honestly cutting edge chip. But to get to where we want to go to solve these important problems in chemistry, in physics, in material science, batteries, energy, and more, we want to get to 1 million qubits. So we're going to keep pushing the performance of our system. We're also going to keep pushing the algorithm and software development so that we can solve these problems.
What does that take, Karina? What does that take in terms of supply chain? What does that take in terms of talent? What does that take in terms of focus?
Yeah, these are all really important questions. I'll start with talent. You mentioned a Nobel Prize winner on our team. We are super proud of Michel Devoret and the entire group of teammates and body of work that's happened over the last many decades. We're super proud of our team. We've got a super talented team of engineers, technicians, research scientists, program managers, and others who are pushing the boundaries of this technology. We've got to keep bringing the best and the brightest to our team to push the performance of what is possible.